Completing the square. A quadratic, such as x squared plus 6x plus 9, is a perfect square. And that's because we can do the following. If you look at x plus 3 all squared, remember that means x plus 3 multiplied by x plus 3, and then we start expanding the brackets. So x times x is x squared, then we get plus 3x, plus another 3x giving us plus 6x altogether, and then finally plus 9. So x squared plus 6x plus 9 is equal to x plus 3 all squared. That's why it's a perfect square. This means that we could write x squared plus 6x plus 10 as x squared plus 6x plus 9 plus 1, and then the x squared plus 6x plus 9 can be written as x plus 3 all squared. So x squared plus 6x plus 10 is x plus 3 all squared plus 1. This is known as completed square form. Completed square form is useful in many ways. It tells us the coordinates of the turning point or vertex of a curve. For the example to the left, this is -3, 1. We get the x coordinate of the vertex by looking for the value that would make the bracket equal to 0. So if x is -3, we have -3 add 3, which is 0. So what we do is change the sign on the number here. The y-coordinate is got from the number here, and the sign stays the same. Two other uses are, it can help us factorize quadratics. It can be used in solving quadratic equations. Complete the square on the following. So we're going to start with x squared plus 6x. Now the way to start is to open a bracket, put a square on it, put at the beginning x, and then take half of this coefficient including the sign. So half of positive 6 is positive 3. Now let's think about x plus 3 squared. If we expand out, we get x squared plus 3x is plus 6x, and then we get plus 9. So the x squared and the 6x is exactly what we want, but we don't want the 9, so what we're going to do is just subtract it, and that's the completed square form of x squared plus 6x. So the next one is x squared minus 8x plus 9, and then we're going to do x squared minus x plus 3. So let's do this one first, doing what we did before. We'll have x and half of -8 squared. Now if you expand that, and I'm not going to go right through the process, you'll get x squared minus 8x plus 16. So the x squared we want, the minus 8x we want, but we only want plus 9, and we have plus 16. So the way to adjust that is just to subtract 7. Now the x squared minus x plus 3. So start with our squared bracket, put x in, and then the coefficient here is -1, so we'll put -1/2 into the bracket. Now if you expand x minus 1/2 squared, you'll get x squared minus x plus 1/4. So the x squared and the minus x work. It's always these first two terms that we get from this bracket. And then we need to adjust. This is 1/4, And we want 3, and remember that 3 is 12 quarters. So what we're going to need to do is add another 11 quarters. We now want to use completing the square to factorize the following. So if we complete the square on this one, so that's going to be x plus 2 all squared. Now that would give me x squared, add 4x, add 4. So we get those two. We get a plus 4, but we want a minus 5, so we need to subtract 9. Now we know the difference of two squares. A squared minus b squared always factorizes to a minus b, a plus b. And in this situation, the a is x plus 2, and the b is 3. So that's going to give me x plus 2 minus 3, and x plus 2 add 3. And then if we just tidy the bracket up, this one becomes x minus 1, and this bracket here becomes x plus 5. And we could re-expand that and show that we do get this. Now with this one, the bracket contains x and negative 5. Now, that would give me x squared minus 10x plus 25, and we only want 21, so we need to take off 4. Then using this again, we get x minus 5 take away 2. Remember, the 4 is b squared, and we want b here. And x minus 5 add 2. And then we'll just tidy that up into x minus 7 and x minus 3. And if we re-expand that, we'll see that we do get this. Use completing the square to solve the following. So let's look at this one. So we need x minus 2 all squared. That would give me x squared minus 4x add 4. We want minus 5, so I'm going to need to take 9 off. So I have x minus 2 all squared. Take away 9 is equal to 0. Now we could factorize from here, but we don't have to. What we can do is say that x minus 2 all squared would be equal to 9. And that means that x minus 2 could be equal to positive or negative 3. 3 times 3 is 9, negative 3 times negative 3 is 9. Then bring the 2 over to this side, and we have 2 plus or minus 3. So x could be 2 plus 3, which is 5, or 2 minus 3, which is negative 1. Now most certainly this example is one that we could have factorized. But this one we would not be able to. So let's think about completing the square. X plus 3, remember 3 is the half of the 6 squared. If we expand that, that gives us x squared plus 6x plus 9. We've met that one before. We only want plus 7, so we're going to have to take off 2. So we're going to have x plus 3 all squared minus 2 equals 0. So x plus 3 all squared would be equal to 2. And that means that x plus 3 would be equal to positive or negative the square root of 2, which is an irrational number. Subtract 3 from both sides, and we get negative 3 plus or minus the square root of 2. So x can be negative 3 plus root 2, or negative 3 take away root 2.